Hi everyone, how are you? How's everything? How are you doing? I hope you did well in your first assignment and now you're full of energy, ready to do the rest of the material and get a very good result by the end of this online semester. So today I'm gonna give you a very quick lecture about one of the main functions of the diodes, which is a rectifier. So if you want to know what's a rectifier, I'll tell you about something that you use every single day. Literally, every single one of you is using it every single day. With what is it? It's your phone charger. Your phone chargers are actually a DC power supply, but you plug them to the wall, and you know that in the wall plugs you have AC. So why do I say they are DC power supply? Because inside them there is a rectifier. What is a rectifier? A rectifier is a circuit that takes an AC signal as an input and gives you a nice clean DC signal at the output. This block diagram here shows that what is inside a rectifier. First, there is a step-down transformer. Why? Because your plug has like 220 volts AC, or in North America they have 120 volt AC. But your phone needs maximum 5 volts. Some phones they only need 3.5 volts. So the first thing that you need to do, you need to step down the voltage, and this part is done with a transformer. This transformer takes 220 or 120 volt as an input and gives you 5 volts AC as an output. Look, transformers, they take AC and they give AC. So this AC voltage needs to turn DC. Look, it was AC and it's still AC, just with a lower magnitude. So it needs to become AC. So we actually give it as an input to a diode rectifier. This diode rectifier, what it does, it actually cuts the negative part and only keeps the positive part. But is it AC or DC? It's none of them. It's not AC anymore because in the sinusoidal shape of AC there is no negative part. But it's not DC yet. DC, we need to have a direct line. So after this stage it goes to a filter. A filter turns this signal into a signal like this because it takes the ripples as much as it can. And right after the filter it goes to a voltage regulator, and the output will look exactly like a direct line. So here is your load, here is your phone at the end that needs a 5 volt clean DC. So I will explain for you within the semester each of these steps, that what do they do exactly. For example, about the voltage regulator, you remember when I was talking about the Zener diode, I told you that voltage regulator is one of the main applications of the Zener diode. And here in the filter part, you remember we make filters with what? With capacitors and resistors, right? So you later on I will actually show you the real circuit of one of these DC power supplies, or what is inside these phone chargers that you use every day. But what we want to talk about is only this first part, the diode rectifier, and we want to find out how it works. Imagine we create a circuit like this. We connect a diode to a power supply which is giving us a DC voltage, in this case, the first case. So what will happen is that if this power supply has a value less than 0.7, nothing is going to pass through this diode. So the output is going to be 0. Look, from minus infinity to 0.7, the output is 0. Only if this power supply gives us a voltage more than 0.7, then we can turn on this diode and the power, and then the output will increase. Actually the output will be the input minus 0.7. This line shows that your V out is Vs, right? It's like a straight line with a slope of 1. But minus this value that we have a voltage drop on the diode. Like most of the time it's 0.7. But let's look back. Imagine this Vs is an AC signal now, is a sinusoidal signal, like this shape. Then when we are on the positive cycle, so the diode is passing for the case that we are more than 0.7, right? So look, it will pass the signal, but if you see this blue one is the output, black one is the input. The blue one is slightly smaller than the black one. Why? This little difference that you see is that 0.7 volts. The blue is 0.7 volts less than the black in the positive cycle. But when it goes to the negative cycle here, it's less than 0.7. So nothing is going to pass. So we're going to have a straight line of 0. Again, when we went to the positive cycle, we're going to pass. Negative cycle, we're not going to pass. So our output is going to be a shape like this. But you remember, in this diagram that I showed you, we want the output to be like this. We wanted our diode rectifier to convert the negative part into a positive part as well. How do I do that? If I only use one diode, the only thing that it does, it cuts the negative part and it only keeps the positive part. This is good, but it's halfway good. It's not that good. Why? Because we are actually losing half of the energy. Because here that we have a negative voltage, still it's energy. So we have to find a way to bring it to the positive side. How this is done in electronic circuits? There are two ways. One way is like this. Look, pay attention. This is actually very interesting. Look, we can have two secondaries in our transformer. So imagine that we want to have, for example, 5 volts in the output, and in our input here is, let's say, 220. We will have our secondary the way that we can get a 5 from the top, we can get a 5 from the bottom. Okay, so we take our ground from here, and these two are connected to each other, like cascaded like this. So when we are on the positive cycle, okay, so here we're on the positive cycle, so here, for example, it's going to be plus 5, right? Here it's going to be 0. So what will happen, this plus 5 can pass through the diode and will come here, and here is 0. So V out is going to be plus 5. When we're in the negative cycle, this is very important. We're in the negative cycle. Here, we're going to have negative. So basically, here that the sign is positive is a negative voltage. Here is positive. So if this is this case, this one is going to pass. Pay attention, look, these signs will be reversed because we're in the negative cycle. This positive will come here, it will become negative. This negative will go here, it will become positive, okay? That's why here is negative, here is positive. This thing is not gonna pass. But this diode, this positive is down. So this diode will start to pass. How is it connected? Look here, the output is going with a wire to the resistor, to our load. And the ground is common. So here is gonna be +5, here is gonna be 0. So as you see, at this, when the input is like this, the output is going to the other way around because of the way that we wired it. This is actually a very nice trick if you think about it. One thing that we need to make sure is that the breakdown voltage of any of these diodes must be high enough the way that when this voltage come here, this 5, when it comes here, for this diode it looks like -5, right, from this direction. So we have to make sure that with -5 this diode doesn't break. So this is the only condition in this. So we have to make sure that these diodes, they have a high enough breakdown voltage not to break. So with this system we're having our full wave rectifier. This one right here was a half-wave rectifier. This one is a full wave rectifier. But there is another trick which is actually pretty neat, and this is called the bridge rectifier. The bridge rectifier, you don't even need to have 2 secondaries in your transformer. You will have only 1 secondary. Instead you will have 4 diodes. But the diodes are connected, look, this way, that D1, D2, D3, D4. Look at the directions of the diodes. Now let's go over it. Imagine we're in the positive cycle. We're in the positive cycle, so here is positive. It's positive, so which of these diodes will pass? Of course D1, because D2, D4 is, the direction is going to be against the direction of the arrow. So D1 will pass. So it will pass, then it reaches this, to this junction. Which one does it choose? Here there is a diode against the direction, so it's not going to pass. But here is a resistor, so the current goes this way, and then it will go back this way and will come to the negative. So the current will pass through the resistor, where here is the positive side, here is the negative side, right? Now imagine the negative cycle. In the negative cycle, here is going to be positive, here is going to be negative. So here, then here is going to be positive, right? Then we get here. So which one will pass? D3 will pass, because D2 is going to be off. So D3 will pass, then we'll come here. D1 is not going to pass, right? It's against the direction. So all the current goes through the resistor and it will go out this way. So you see how neat, with just 4 diodes we created a very cool full wave rectifier. So I will let you go over this yourself as well. It's on lecture note 18. It's explained very well, and please come to class with your questions. Have fun, take care, and see you online in class tomorrow.